Okay, this is the practice on arithmetic sequences and series worksheet that we did. So let's go through the first one here. We want to determine if this is arithmetic. If it is, find a common difference, find the term stated, and then the explicit formula, recursive formula, and the next three terms. If it's not, we say it's not, we're good. So the key here to be arithmetic, you need to have a common difference for, as far as the pattern going on. So it looks like this one, there's a +4, and that continues to work. So we're good to go. It is arithmetic. That common difference we just found is 4. So the common difference is whatever that pattern is. Okay, let's see if we can find, we need a term in the formula. But before that, let's get a formula. Let's do that next. So formula is going to say, again, if this is a1, a sub 2, a sub 3, and so on, we want a formula for any term we want, a sub n. And the general case is always going to be, if you notice what's going on, we're always starting with the first term, and then we're adding 4. So in general, we're adding whatever that d is. And then the little trick is we're actually adding it n minus 1 time. So for example, to get the second term, right here, we only added 4 once. Okay. To get the third term, we started with 2, and we only added 4 twice. So whatever that term number is, you're adding 4 one less than that number of times. That's why whatever term you want, you're adding that common difference n minus 1 times. Okay, so for this specific problem, we start throwing some numbers in here. Again, the first term was 2. We're adding 4, and it's always n minus 1 times. And then you just do a little algebra simplification here and combine some like terms. So the 2 and the minus 4 become a -2 plus 4n. Okay, or we could have said 4n minus 2. Okay, and let me be careful how I write this an. I want to make sure we're clear. That n is it's lower, it's a subscript. Okay, it's a term number. Okay, so that is our explicit formula. You can get any term you want by plugging into that formula. You can get the 100th term, plug in 100 for n. Okay, so let's get the 22nd term. Okay, a sub 22 is what they asked us for. Using that formula we just got, I know it's -2 plus 4 times 22. Okay, so if we do a little calculation here, the 4 times the 22 sounds like 88 to me. Okay, so -2 plus 88 is 86. Okay, so the 22nd term, okay, if this thing, were to continue for really far, the 22nd thing in the list would be 86. Okay, so we got that. We got the term done. We got the explicit formula. Let's get the recursive formula. Okay, so the recursive formula is a little different than the explicit. So this one up here is explicit because we can find any term we want. Okay, the recursive is going to require you to use the previous term to get the next term. So there's kind of two ways to write a recursive formula. One way is to say, all right, how would I get the n plus 1 term? Okay, using the nth term. Like, how would I get the 10th term if you knew the 9th term? So with these, it's actually pretty straightforward. We're just adding 4, right, every time. If I give you any given term, you can get the following term by just adding 4 to it. So just to write that within the notation here, a of n plus 1 will equal a of n, and then we're just simply adding a 4 to that at the end. Okay, so again, just keep in mind, this just means the term right before this. Okay, the subscript they're one number apart, right? One subscript is n, one subscript is n plus 1. Okay, so that's our recursive form. And then getting the next three terms, we're just kind of following the pattern, 18, 22, and 26. Okay. All right, number 2, just real quick looking at this. Let's looking at the pattern here. It looks like we're doing a -2. Then we're doing a -4, then a -8. Okay, this one's actually not an arithmetic sequence. Okay, and we haven't really looked into those yet. This one, it appears we're actually multiplying by 2 each time. That would be a geometric sequence, which we'll talk about coming up. Okay, so nothing else we can do for that one. All right, number 3, given the first term and the common difference, find the 52nd term. Okay, so again, we need some sort of formula. I want a formula for a sub n. So I can plug 52 in for n. And we saw how that worked in the previous example. It's always the first term plus whatever d is times n minus 1. Okay, so in this case, negative 11, again, plus 9n minus 9. When we clean that up a little bit, combining the negative 11 and the minus 9, we should get a negative 20 plus 9n. And then we can simply plug in the 52 now, because that's the term number we want. So that's going to be our n here, and actually here as well. So a sub 52 will be negative 20 plus 9 times 52. Okay, and I'm going to throw that into the trusty calculator. And I'm getting 448 okay, for the 52nd term. Okay, we can kind of just look at what they gave us and see if that makes sense. So we're starting with negative 11, we're adding 9. Okay, so our number should be getting bigger, and we're going out fairly far, 52 terms out, so 448 seems like it's reasonable. Okay, number 5, so I'm kind of jumping around, I'm not doing every single problem. Number 5, given the recursive formula, find the common difference, the first 5 terms, and then find an explicit formula. Okay, so again, think about this. Here's a recursive formula right here. Okay, that's recursive. And if you think about how a sequence works, again, it's A1, then A2. Somewhere there's some AN. The next term is AN plus 1. The next would be AN plus 2, and so on. Okay. So what they're telling us basically is to get this term, you have to take the term right before it and add 9 to it. Okay, so there's going to be like a plus 9 going on. That's going to be the pattern to this guy. That's the common difference. Okay, so D is 9. Okay, let's list the first 5 terms then. Okay, so to get a recursive started, they have to give you the first term, or they have to give you a term. And in this case, they were nice and gave us the first term. So I know the first term is negative 17, and we are simply following the pattern of adding 9 each time. Okay, so if we add 9, we should get up to negative 8. If we add 9 to that, we should get up to 1. If we add 9, and I think that's 5 terms we need. 1, 2, 3, 4, 5. Yep. So that's the beginning of this sequence, and of course it would continue on. Okay, then to get an explicit formula, now that we know what we're dealing with, and we kind of actually knew enough info to do this once we got this d value, because again this is recursive here. The explicit is going to be a sub n, like we did previously, is always the first term plus the difference, okay, which we knew was 9 times n minus 1. And we're just going to do the algebra on that, simplify, so negative 17 plus 9n minus 9, which simplifies to negative 26 plus 9n. And that's our recursive, or that's our explicit, okay? Okay, remember explicit means that you can plug in any n you want and just get an answer. Okay, the recursive is when you're dealing with n plus 1s and n's, subscripts. Okay, number 6, jumping up to series here. So a series, again, is the sum of the first n terms of a sequence. Okay, so remember, a sequence is just like a list or a pattern. Once you start adding those terms together, you get what's called a series. So we had a formula we talked about in class. Remember the example with Gauss, how we listed the sequence and then listed it backwards and had 2 lines and kind of went through that whole deal. And I don't have time to go through again right now, but we ended up eventually with the formula. The sum of the first n terms is always going to be n over 2 times a1 plus an. So basically the first term plus the last term. And then we need to times that by n over 2, because doing a list that way actually gives you twice the sum you're looking for. So we talked about that in class a little bit. So let's do that. So there's a couple ways to do this. Keep in mind this right here we had a formula for earlier. So let me kind of pull that out. Remember that a sub n always equals a1 plus d times n minus 1 from before, right? So that's just for that part. So it looks like we could probably just start plugging in and actually just kind of modify our formula a little bit if we wanted to. This is one option here. Substituting that formula for an, remember, is a1 plus d times n minus 1. Okay, so let me just kind of show what I just kind of substituted, right? This is just right here in place of a sub n, right? So it's kind of a substitution, and what it allows you to do, it's basically, instead of going and finding the 15th term with the formula, you could just substitute the info we know. Because look, I mean, going through this formula, we need an n, we know n. We need a1, we know a1. We need d, we know d. Okay, so I can sub everything into this formula just from what was given without doing any previous calculation. So let's do that. Let's set that up. So the sum, they want us to sum the first 15 terms. Okay, it's going to be 15 over 2. The first term is 7. Okay, and I'm at this step now. So again, another 7 plus d, which was 3, times n minus 1. And you can almost just do this as like an order of operations kind of deal. Okay, so this is just one option. Again, you could go through and find everything individually first and then plug it into the formula. But this just kind of turns into a calculator problem, and I'm getting an answer of 420. Okay, so it's perfectly fine to do that, and it's kind of good actually to know that little trick where you can replace the a sub n with its equivalent formula and just manipulate the formulas to what you need. Okay, so 420 for number 7. Okay, here's another one. This one's given in sigma notation. So really what we're looking for is, remember, they're giving you limits of for the sum here. So you're starting with an m of 1 going in there, and you're going all the way through every number. M would be 1, 2, 3, all the way up to 20. So the first couple terms here, just to see this the long way, would be 8 times 1 minus 5. That would be the first term. 20. Yeah. The second term would then be 8 times 2 minus 5. So see, I'm just kind of simply plugging in values for m, and I would go all the way up to 20, and I would add them all up. Okay, now the easiest way to do this is on your calculator. Okay, you can also use the formula I gave you before and find the 20th term and use, let me give you that formula one more time. So there's some options here. You could do the n over 2 times a1 plus a20, okay, which in this case would be 20 over 2 times, so the first term, which is right here, looks like it's going to be 8 minus 5, or 3. The 20th term would be 8 times 20. So this is going to be 8 times 20 minus 5. So 160 minus 5. Okay, so this is one way to do this problem, and it's really not that bad. And if I calculate that out, I'm getting 1580. Okay, but this again, it can also be done on the calculator. So let me pull that up real quick as well. Okay, so on the calculator, we're going to go into, it's this math button on the left here, and you'll see on the first option is, I'm pressed up to kind of get to the bottom of the list. This list, there's a summation figure there, and you're going to get basically the blank setup for the summation notation. So if you need to put in a variable, I usually just use x here, and x in our case was going from 1 to 20. Okay, so I'm just using the directional pad to kind of fill in exactly the way the problem was given to us. And then we put the expression in. So again, for us this time, it was 8x minus 5. Okay, remember, just use x. It's just easiest. Oh, not 2. 8x minus 5. And it's going to just quickly do the numerical part. Okay, so it does the sum for you quickly, but make sure you're still clear what's going on. Again, make sure you know, we were doing the first term plus the second term plus all the way up to this ended up being the 20th term, and we were adding those all up. Okay. All right, number 9. This one we could also use the same formula if you just want to check an answer on number 9. Number 9 should be 403. Okay, here's actually the other answers if you want to check real quick while you're looking at this. So I know we didn't do every problem. Number 10 we will do in class. It kind of combines everything, so it's actually a really good problem. Part E is a little bit tricky, so we'll make sure to hit that in class. All right, so hopefully that helped.